Dear Sir and Madam, it's a great honor to be here today to share practical solutions that contribute to the continuous improvement policy of the D&E division, especially in the field of construction project management. In today's presentation, the Construction Management Department would like to introduce the topic, Measures to Mitigate Environmental Impact Risks on Neighboring Residential Areas During Construction. This proposal is intended to be applied initially to the H14-3 project and potentially scaled up for other similar projects in the future. Our presentation is structured into 6 main parts. We'll start with an overview of the project, then move on to identifying the root causes of potential risks, our risk response plan, the proposed roadmap, and finally, the conclusion. We hope this journey gives you valuable insights into the challenges and solutions we are implementing. The H14-3 project has a total GFA of over 21,000 square meters and a building height of 47.2 meters from the ground floor. It includes 2 basements, 12 above-ground floors, and a rooftop level, making it a large-scale development that demands high standards in both technical execution and project management. The project is located on Ha Hui Tap Street, adjacent to 3 residential zones, Mayan, Maikan, and Fujia. This proximity poses significant challenges in controlling environmental impacts, such as dust, noise, and vibration, on nearby households during construction. In reality, throughout the executing process, we have received complaints from nearby residents. The environmental impacts caused by construction not only cause discomfort to surrounding residents, but also directly affect the progress, even the image and reputation of the company. Therefore, identifying these issues early and proactively implementing mitigation strategies is essential. When identifying potential risks, we categorize them into 8 key groups: noise, vibration, dust, odors, wastewater, construction waste, traffic safety and community interaction, and the cleanliness of areas surrounding the site. These risks, if not managed well, can directly affect the health, well-being, and overall quality of life of nearby residents, who are also valued customers of Fumaiham. Given the nature of construction, these risks cannot be entirely avoided or transferred. Therefore, proactive measures must be taken to reduce their probability and impact. In previous projects, D&E has implemented effective controls such as construction time monitoring, HSE management within and outside the site, and waste treatment in compliance with state regulations, etc. Therefore, these methods will not be presented in detail in the response plan section, but only present new points with red numbers. With the special location close to residential areas of the H14-3 project, CMD proposes some new solutions to minimize environmental risks, which will be presented in detail in the following part. The first step is to monitor and measure environmental impact indicators caused by construction activities. We have hired independent, professional, and capable units to conduct surveys and monitor the following contents: current conditions of nearby buildings and road infrastructure, subsidence and tilting monitoring for surrounding structures and roads, noise levels, vibration intensity, and emission concentrations. These surveys will be carried out before and after key project milestones, as well as periodically during construction. The data will serve as a solid basis for corrective action when needed. Before commencing construction, we will review and assess the main equipment used on-site, focusing on production year, maintenance status, fuel type, and emissions/noise output, to provide solutions for choosing the equipment. For example, the H14-3 project team coordinated with Fanvu contractor to measure the noise level of mechanical equipment before construction. The test results were the basis for adjusting the equipment selection plan, ensuring both construction site conditions and meeting noise standards for surrounding residential areas. The third measure we propose is to install public information boards displaying environmental indicators such as noise levels, vibration, and emission concentrations. These boards will serve as both a reminder for construction crews to maintain control, increase communication to build trust and transparency with local communities. In addition, we aim to implement continuous, real-time monitoring of environmental data. This system will enable the project team and stakeholders to respond proactively before issues escalate. We plan to use sensors that track environmental indicators and transmit real-time data via mobile apps and web platforms. Sensors can be installed around the perimeter fencing for easy access, or near residential buildings for more accurate data. Each option comes with its own pros and cons. Each monitoring unit will include 1 electric cabinet, 3 types of sensors: noise, emission levels, and vibration. The noise and emission sensors will be mounted on top of the fence, while the vibration sensor will be embedded in the ground. We have discussed this technology solution with a specialized company, in this case, P-Home, a Vietnamese enterprise operating in the field of technology and software. Such companies are capable of providing hardware equipment, software and application development according to the specific requirements of the project. Here are some simulated images of the application interface on the phone and website provided by P-Home. Through this platform, parties such as project team, supervision consultant, contractor, can all monitor environmental indicators in real time and handle immediately when detecting risks exceeding the allowable threshold. After monitoring, our next focus is prevention, starting with noise and dust control. One solution was learned from presentation shared after CMD's business trip to China, the temporary soundproof fence system. H14-3 currently uses the standard 4-meter fence of Fumaihong. To enhance sound absorption while minimizing replacement cost, we propose retain the existing fence frame, but reinforce it to raise it to 5 m. Attach a sound-absorbing module fence to the top of the fence. In there, the lower 2 meters will remain as regular fencing, while the upper 3 meters will consist of the new acoustic modules. The top meter will be slanted to improve sound diffusion, reduce acoustic diffraction, and optionally hold potted plants to enhance aesthetics. These sound-absorbing fence module systems have been widely used for highway projects, construction projects in developed countries such as Taiwan, China. Therefore, there are also many suppliers in the foreign market. Here is the reference technical information of a supplier named Hubei Jinbiao from Singapore, in which, according to their brochure, the technical specifications of their sound-absorbing system have STC equals 27 and NRC equals 0.7. A pretty good number. In terms of structure, it is similar to the sound-absorbing systems commonly used in Vietnam, still including rock-wool core to absorb sound, galvanized steel plate with special sound-absorbing holes to prevent rainwater penetration, fiberglass layer to prevent dust and protect the inner core. The system is supported by C-shaped steel braces to reinforce the old fence for easier installation and reuse. With this modular system, DNE can maintain and reuse panels in future projects. To apply the modular installation characteristics of soundproofing panels, we are considering the use of portable noise control barriers. These modules are mounted on wheels, making them easy to move and effectively providing localized soundproofing for high-noise operations such as concrete breaking, aluminum formwork repair, installation and removing, and air duct fabrication. These barriers offer similar sound absorption coefficients as the previously mentioned modules and are typically manufactured in dimensions of 2 by 2.5 meters. Regarding the scaffolding and external protective netting system, we propose the use of a PVC-coated mesh integrated with a polyester soundproofing layer. This type of netting is commonly used in high-rise projects in city centers of developed countries. Not only does it help block dust, odors, and debris, but it also provides soundproofing with a technical specification of up to 11 dB, according to the manufacturer's brochure. For the H14-3 project, we recommend continuing to use the traditional open mesh type on the upper floors, while incorporating modular netting as learned from the CMD business trip and the C12B project. Given that the adjacent Mayan and Maikan buildings are only around 23 meters tall, we propose the application of soundproof PVC mesh starting from the 9th floor, approximately 30 meters in height, downward, to mitigate the risks of dust, odors, and noise from the construction site affecting the nearby residential area. This will also help reduce costs related to netting installation and minimize the applied height to ensure the wind load-bearing capacity of the scaffolding. Furthermore, we will pay special attention to arranging mesh in certain areas to allow natural light and ventilation, and to increasing forced ventilation and lighting to meet the requirements for inside construction. The 8th solution is to combine the use of wooden formwork in the aluminum formwork system with two main goals. First is to meet the specific design of the project with curved facades and asynchrony between floors, requiring flexibility in handling shapes. The second is to limit the noise generated during the editing, installation, and removing of aluminum formwork. We will also tighten control over the process of dismantling and assembling aluminum formwork, limit rough handling, arrange padding underneath, and control the number of times wooden formwork is reused to ensure the quality of the concrete surface. Finally, we proactively combine traditional dust control methods and modern technology to achieve higher efficiency. During the bidding process, the use of floor grinders and sanders with integrated dust extraction systems was included in the technical standards. In addition, learning from the CMD business trip to China, we will also coordinate with the contractor to consider combining manual watering and using mist sprayers in areas with large dust generation. In Part 5, we will present the implementation roadmap. This table will include the status of the risk mitigation plan, expected deployment timelines, preliminary costs, and additional notes. Task 1 and 2. These tasks have already been deployed on-site. Regarding costs, for Task 1, we only signed a contract with an additional company to survey the neighboring project site conditions at an approximate cost of VND 300 million. The remaining two factors have been coordinated with the contractor, with costs covered by them. Task 3. Installation of the display panels will begin around Q3 of 2025. Tasks 4 to 7. These tasks require close collaboration with departments such as technical, design, and commercial department to evaluate and optimize technical aspects, costs, and aesthetics. We aim to start these tasks in Q4 of 2025, which coincides with the completion of the underground structure and the initiation of ground floor construction. Thus, these activities will have minimal impact on the surrounding residents. However, we are working to accelerate coordination to begin implementation as early as possible. Tasks 8 and 9. These tasks will be implemented in collaboration with the main contractor as soon as the respective contract package commences. Construction activities such as machinery operation, structure work, material transport, and waste management can cause noise, vibration, dust, odors, wastewater, debris, and traffic risks. If not properly managed, these impacts may harm the environment, affect public health, and damage the project's reputation. Strict compliance with environmental regulations, proactive risk management, use of eco-friendly solutions, and active communication with the community are essential to minimize impacts and enhance the project's professional image as well as progress to Fu Mai Hung 2.0. Thank you very much to the management board and members for listening. Sincere appreciation is extended to Mr. Andy Huang, Mr. Nguyen Tan Lok, and all members of the CMD for the valuable instruction, support, and guidance in this presentation.